normal conditions, a single atom is composed of a dense nucleus made up of the elementary particles called protons and neutrons, which are themselves made up of smaller fundamental particles called quarks. Yay! I saw a documentary on mining. They found a mountain of copper in Southeast Asia. Well, don't take that copper for granted either. Copper is which atomic number? Copper is zinc. I think it's 29. So do not take copper for granted either. We did not make it, I assure you. What we made is actually oceans. We did make oceans, so maybe we can take the oceans for granted. But even then I wouldn't, because what's in the ocean we did not make. I'm going to Kansas. Very nice. So good thing that Dr. Krauss is giving us a reminder on the atom and its individual elements and things like that, individual parts. So there's the nucleus, it's got the protons and neutrons inside a nucleus, and as you know, because we've discussed it earlier in particle physics, neutrons and protons again are made up of quarks. Okay, so quarks are a fundamental particle that make up the subatomic particles called protons and neutrons. We used to think that the proton might be it, as in it's a fundamental particle, that's it. Later on, the neutron was actually discovered, and then later on, as particle physics made more progress, we actually saw that quarks, these more fundamental particles, make up the protons and the neutrons. Okay, so all of that is to say that, by the way, let me give you a little reminder. There are three fundamental particles. These are leptons, quarks, and bosons. We have talked about examples of these things. Leptons are, for example, something like an electron is an example of a lepton, and quarks is another fundamental type of particle which we're mentioning here, and bosons are something like light, photons. Light is made up of bosons known as photons. So that sort of stuff. So quarks are fundamental particles that can make up something like that, do make up the protons and neutrons that are in our regular atoms. The nucleus contains more than 99.9% of the total mass of the atom. Oh wow, abandoned gold mine? Goodness. There's an abandoned gold mine about an hour from where I live, but it's here in Virginia, not California. Consciousness is fundamental. So typically the nucleus contains more than 99.9% of the total mass of the atom. It is surrounded by a cloud of electrons that occupy a space more than 10,000 times larger in radius than the nucleus, but carrying almost none of the mass of the atom. So you might know that atoms, by the way, the name of this book is also called Atom. Atoms are kind of empty, as in the nucleus is very dense, and the sort of volume occupied by the nucleus is much smaller than sort of the cloud of electrons that surround the nucleus. And it's only one electron in the case of the hydrogen atom, and only two electrons in the case of the helium atom. But consider if you had a bigger atom than that, of one of these heavier nuclei that we're mentioning, then of course there would be more electrons in more such clouds that surround the nucleus. But actually it's kind of empty because the nucleus is not occupying that much space in an atom. By cloud, I actually mean nothing of the sort, says Dr. Lawrence Krauss. Cloud is simply a name we gave to the electron distribution because we have no real appropriate label. It is impossible to describe in words what the electrons do as they surround the nucleus. At this scale, they are described by the laws of quantum mechanics. Remember our favorite topic, quantum mechanics, how people were very upset indeed that quantum mechanics has an uncertain and probabilistic nature, and we can't always say where a particle really is. We would only know its probabilistic distribution. So that's what's going on here. So something like electron, it's so small, it does not follow classical physics. It follows quantum mechanics or quantum physics. And in quantum physics, answers are given as probabilities, not as certainties, okay? So it's impossible to describe in words what the electrons do as they surround the nucleus. At this scale, they're described by the laws of quantum mechanics, my favorite, under which material objects behave